Okay, back to chapter 3. Let's look at 3-2. This one requires a little bit of knowledge from chapter 1 because we're trying to figure out what kind of molecule we got. So we got a hydrocarbon. Density is equal to 0.103 pounds per cubic foot at P equals 14.7 psi, and temperature equals 100 degrees F, which we already know would be 560 Rankine. We convert, which we're going to already. Oops, come into focus there. Tricking it here. Hello. There we go. So, trying to figure out the chemical analysis tells us that we've got something that has, let's see, 2 hydrogen atoms. There we go. 2 hydrogen atoms for each carbon atom. So for each carbon atom, there's 2 hydrogens. So we're going to have to figure that out. So if we assume this hydrocarbon, where are we at? We assume this hydrocarbon acts like an ideal gas. So ideal. So we're back to our old property behavior. So if we remember, rho equals molecular mass over actual mass. So that's what we're looking, oh, no, not mass. Molecular mass over volume would be the molecular density, and that's going to equal to Pm over RT. So this is little m. This is your actual mass. That's my fault. So this is mass. This is molecular mass. This should be a lowercase m. That's uppercase m. Sorry for the confusion there. So our density equals to 0.103 pounds per cubic foot. And that's going to equal to 14.7 psi times m, which we don't know yet. M, that's pounds per pound mole, divided by 10.732, because we know what units we're working in. Q psi over pound mole R, and that's times 560 R. So these units cancel out. This would cancel out. So what we ultimately end up with here, we've got to resolve it around, is our m is going to equal to 0.103 times 10.732, 560 divided by 14. Is that right? Yeah, that's right. So let's go to the calculator and punch this out. 0.103, 10.732 times 560 divided by 14.7. That equals 4211 pounds per pound mole. Yeah, actually that shouldn't have been there. There's no pound mole there, my fault. So here it is. So things we need to know: carbon has molecular mass of about 12, hydrogen has 1 of 1, correct? So 12 goes into there how many times? Let's say 3 times. So there's 3 carbons And so 3 times 12, that would give us 36. And that would leave 42 minus 36 is going to give us, what is that? 4, 5, 6, 6 and change. So that gives us 6 hydrogens, which is what we were saying up here. We have 2 hydrogens for every carbon. So 3 carbons, 3 times 2 is 6, 6 hydrogens. And that's going to be equal to your basically here 6.11 more or less. So what do we have here? If you remember, so that would be carbons, 3 carbon guys, and each one has 2 hydrogens. So here's the H, there's the H, 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 and H there. So these have double bonds. So decane or pro 3. Propane would be single bonds. Propene would be double bonds. And propyne would be triple. So we got the double bonds. So here's our molecule. Talking about propene here.